In the previous examples, we showed you how to use synthetic division to narrow down all the linear factors of a polynomial function. However, if you were just asked to solve a polynomial equation and we were given no indication of what one of the factors may be, you may spend a large part of your time just guessing and trying to figure out what the possibilities are. So this is where our next theorem comes into play, the rational root theorem. What the rational root theorem does is it allows us to narrow down the possibilities of the zeros based off the factors of the leading coefficient and the factors of the constant term. So if you read real closely the rational root theorem here, you can see that we get this p over q value, which p represents the factors of the constant term, and the q represents the factors of the leading coefficient. And when you do this, you kind of narrow down all of the possible zeros. Now, you will actually use these to determine what the linear factors are, and there may be a little bit of a trial and error process here where you have to try one of them and see if it works in synthetic division, and if it does, you've found one and you can move forward. If it doesn't, you have to try another one. So we'll talk about that a little bit in the example problem. So let's show you how we're going to use rational root theorem in this example down here. So example 1. First thing we want to do is we just want to get in the habit of listing all the possible rational zeros. And if you look, we see that the p, which is the factors of the constant value, 15, we list all those possible values. That's a 1, a 3, a 5, and a 15. So just some prime factorization going on there. Secondly, the q are all the factors of the leading coefficient, which is 1, which makes our p over q possibilities a lot easier, because since we have a leading coefficient of 1, we're not going to end up with any fractional values. Now keep in mind, we could end up having a positive or negative version of these, because you could have a negative factor of 1 or negative factor of 15. So you have to have the plus and minus version of each of these possible factors. Now, you can see here we have plus or minus 1, 3, 5, and 15. So that gives us 8 possible factors. And of course, we don't know which one of those are, but that's a lot less than an infinite number of possibilities. So the rational root theorem here has narrowed our possible zeros down to 8 possible zeros. And so that's going to limit us to having to guess and check a whole bunch of other factors. Now, we still have to do a good job of narrowing it down within these given 8. Now, part B says to go ahead and find all the rational zeros. Generally speaking, you obviously want to start off with some of the easier ones. A 1 or a negative 1 is a good starting place. And so what we've done in part B here, we've just started to test possible rational zeros to see if it is a given factor based off of our factor theorem. So you can see in part B, I've tested 2 of them just so you can see the difference. I tested a 1 and I tested a negative 1 as a possible factor. And I set up synthetic division for both of them. And you can see the 1 actually gives us a remainder of 0, which tells us that it is a factor. And the negative 1 gives us an output of 24, which means that is not a 0 or not a factor. Now, later on when we're graphing polynomial functions, that negative 1 with an output of 24 actually has some value. So it's not a total waste of time when graphing, because we now know that negative 1 and 24 is an output or a point on the given graph. So that will come in handy later. But as far as trying to find the zeros, or eventually just trying to find all the solutions to a polynomial function, that's not going to help us out a whole lot. So here in part B, we see that 1 is a given factor, and of course we have to write that as x minus 1, because the 1 is representing the c value. And so now we can take that and take the pressed polynomial and factor it, and then write all of the given factors as we did in a previous problem. So now we're taking it a step farther, where you have to use the rational root theorem to hopefully come up with your own factors or your own roots of the polynomial, and you no longer are being given one of the factors. So And then when you finish, as always, just as a good check to make sure you did this correctly, multiply all the linear factors back together to see if you come up with the original polynomial function. Okay, so that's a good example of using the rational root theorem to take this problem a step farther. In the next couple of videos, we're just going to do a couple sample problems. So go ahead and move on and work the next sample problem number 3, as best you can, and then come back to the next video and watch the solution.